A'udhu Bismillahirrahmanirrahim. Now, previously, we were discussing about the interpretation of the liver function test. It is a part 1 of session 1 I have described, and in which I have told you about what do you mean by the liver function tests and what are the results which are obtained as a parameter, which is called the liver function parameters. What are their importance? It depends upon the basic knowledge of the anatomy and the physiology, specifically speaking the metabolism of the bilirubin. One should repeat often. Now this is, I am a Professor Sayyid Ali, a visiting professor of Janassin Medical University, talking to you now the second part of discussion. Now previously I have told you that the bilirubin definitely will be converted into biliverdin, and biliverdin, by a carrying protein, it will come to the liver hepatocytes, and by endocytosis it will enter into the, because it's a big molecule, it will enter into the hepatocyte. It is a factory, a unique factory which is created by the nature, and it will bind with the protein inside, and that is called the conjugation. The conjugation occurs in the liver cells, and then the conjugated bilirubin will be exported as a bile acids and salts, which we call as pigmented. They are pigments, bile pigments, you can say. They are released into the interstitial spaces, collected by the interstitium as the ducts, which are called the biliary canaliculi. They gathered and forming the right hepatic and the left hepatic ducts, and then it will also combine with the gallbladder duct, that is called the cystic duct, and then it is known as what is known as the common bile duct. Bile duct is forming like this. It will enter in the second part of the duodenum, where the sphincter udi is there to control it, release into the intestine, and then I said that it is essential for the lipids for their metabolism, these bile salts and bile acids, and in this fashion they will absorb, otherwise they cannot be absorbed properly. And most of this is converted into then afterwards into urobilinogen at the end. The urobilinogen will be converted into urobilin. So urobilinogen will be converted into urobilin and it will absorb into the blood 80%, and again the circulation, enterohepatic circulation will occur, and some of this absorbed bilirubin, of course, are excreted into the urine also. But 20% of this bilinogen in the intestine will be converted into stercobilinogen, which will give the pigment of the specific coloration to the feces. Now this cycle should be repeated by you often. You should repeat it. On the basis of this, there are two types of the hyperbilirubinemia, means that is bilirubin, total bilirubin, which is 0.8 to 1, usually in most of the cases. It may be more than 1.2, not more than 1.2 in normal individuals. If it is more than that, 1.2 total bilirubin, then you will go for the one done blood test, which will tell you about how much it is the conjugated and how much it is the unconjugated bilirubin. 1.2 to 3, it is called latent jaundice. More than 3 will be appear in the clinically as the yellow discoloration of the sclera and the skin, and you can detect it by clinical examination. What's important is this: there are two types of bilirubin. One is unconjugated, and second one is conjugated. Now this concept should be clear, absolutely. Now you can obtain, for example, if the conjugated bilirubin is given with total bilirubin, you minus total bilirubin from the conjugated bilirubin should be minused, and the unconjugated bilirubin can be calculated and vice versa. It should be within normal range, of course, which is given in front of every test. There is usually a mixture of the normal person. There is a mixture of the unconjugated and the conjugated bilirubin. In children, mostly they are unconjugated, and adults, it is very near the conjugated bilirubins are more than the unconjugated bilirubin, because the liver, they are now active and it can conjugate if the child grows. So there is a mixture of the unconjugated and the conjugated bilirubin in the normal persons. If the bilirubin exceeds, total bilirubin exceeds than that, you should calculate how much is the conjugated and how much is the unconjugated. So there is what is called the predominant type of the unconjugated hyperbilirubinemia, and there are predominant conjugated hyperbilirubinemia. There are two types of the jaundice. Unconjugated hyperbilirubinemia, repeat the cycle again. It will be, the cell will die, RBC will die, and it will release heme, and globin heme will convert it by macrophages into biliverdin. It will carry it into the liver, definitely, by haptoglobins and other specific proteins are present. And at that site of the liver, for example, this is the part of for example, hepatocyte. It will enter, and it needs the carrier protein here at the cell surface, and then endocytosis will occur, and it will go inside. So how the unconjugated hyperbilirubinemia is possible? Increased turnover of the RBC is possible, yes. Or there will be a deficiency of reticuloendothelial system, which is there, which is converting actually this, and this is hyperactive. It is possible like this. More bilirubin, definitely more bilirubin will be found. One of the important things is increase bilirubin production. That is substrate. And secondly, there will be entry. If they are entering into the hepatocyte, there is hindrance there. So therefore, they decrease hepatic conjugation. Inside the cell, the enzymes are not properly working. The proteins, which are the binding proteins inside, conjugated proteins, they are not present in higher quantity. Then definitely it will expel again into the blood as the unconjugated bilirubin. So there are two mechanisms. One is increased bilirubin production, and there is decreased hepatic conjugation. The increased bilirubin production, example is hemolysis, all hemolytic anemias, whether they are related with disorders of the hemoglobin, or whether it is autoimmune, or whatever it is. In the there are many causes of hemolysis, intravascular hemolysis or extravascular hemolysis. Extra hemolysis is that extravascular, the reabsorption of the large hematomas. So there will be increased bilirubin production. Now the suggestive findings in these cases, a few or no clinical manifestation of beta-biliary disease, no. Secondly, there may be chances of anemia because of the increased turnover, anemia will be there, jaundice, splenomegaly, because it should highly function, RE cell will be Hyperplasia will be there in the spleen, and there will be formation of the gallstone occur because of the more of the bile pigments which are excreting into this, the formation of the pigmented stones in the gallbladder. And serum bilirubin level is 4 to 6 milligram or more than that, and it may be normal. All tests below which I have said to you, they are normal. ALT, AST, alkaline phosphatase, gamma GT may be normal in these cases. And normal color urine, because the color is formed by the urobilin. The urobilin is formed in intestine. So the color here is normal. And there are features of hemolysis. Specific feature of hemolysis are seen. Clinically is will be said, or biochemically it can be proved. It is possible. Decreased hepatic conjugation. It is a syndrome which is called Gilbert syndrome, in which there is a qualitative defect in the hepatocytes, and that is where the conjugation is not possible. And there is another syndrome which is called Crigler-Najjar syndrome type 1, or type 3 rather, which is it is a mild type of the Crigler-Najjar, in which again the conjugation is poor, very poor. The Gilbert syndrome and Crigler-Najjar syndrome. These are the syndromes which are related to the genetic predisposition to the patient. So what is the LFT in this case? Typically, total bilirubin will be increased, and the indirect, or we can say the unconjugated bilirubin will be higher. And the enzymes of the liver will be normal. There are evidence of the jaundice and anemia in the patient if we see. But important thing in the LFTs is the normal enzyme levels. These are very important points. This is a typical picture of the unconjugated, predominant unconjugated hyperbilirubinemia. As far as the second one, which is called the dominant conjugated hyperbilirubinemia, it means the conjugation actually occurs properly. After conjugation, many possibility that export of this conjugation from the outside the cell by exotic sources is not possible, because again it needs carrier proteins. And you can see the possibility of there is a deficiency of the enzymes binding or conjugating enzymes. They are deficient, whether quantitative or qualitative. Possibility of there is there when the conjugated bilirubin is not possibly transported out of the canaliculi, means stasis there, intrahepatic cholestasis, for example. And then the possibility that is outside the liver there is obstruction to the excretion, that is called extrahepatic cholestasis. And there will be what is called the hereditary disorders. So hepatocytes are at the stake. The conjugation occurs in the hepatocytes, at the stake. And in these cases, all of them, let's see this, the hepatocellular dysfunction, viral hepatitis or any hepatitis, drugs, cirrhosis, hepatocellular carcinoma, a very, very important hepatocellular dysfunction. It is called what is called hepatocellular jaundice also. That's why. In this case, the AST and ALT will be higher, much higher, with conjugated bilirubins are more than the unconjugated bilirubin. Second is the intrahepatic cholestasis. Inside the liver, there is the canaliculi, the excretion is very, very slow. For example, in alcoholic liver disease, drugs which can cause cholestasis, toxins, septicemia, hepatitis can cause, because swelling of the cells can cause it, obstruction. Primary biliary cirrhosis, PBC, the primary biliary cirrhosis. Again, this is a very idiopathic type of cirrhosis which hinders the excretion of the bile. The suggested finding are the alkaline phosphatase in this case and gamma GT 3 times more. Gamma GT is to the alkaline phosphate ratio is more now. Gamma GT is more highly, it is higher than the alkaline phosphatase. This is the study done by many of us and found like this. And maybe the aminotransferase levels may be higher with it, but not much higher level, like this 500, 600, 1000. It's possibly that it is a higher to 3 times. And then there will be possibility of the extrahepatic cholestasis, like the bile duct or the common bile duct or common hepatic duct or near the intestine with obstruction, like the common bile duct stone, cholelithiasis. Pancreatic cancer is compressing it at the sphincter of Udai, and the common bile duct stricture, the carcinomas, etc., acute cholangitis, relapsing cholangitis, ascending cholangitis. Again, the same one. Here, the alkaline phosphate is higher, very high, in comparison with the GTT, which is also high. And ALT, they are increased to 3 times, 2 times increase, not much, 5 times, 7 times, 10 times increment in the first one. Dysfunction of the liver. In hepatocellular jaundice, it is post-hepatic jaundice, that is we are talking about. And there are hereditary disorders like Stevens-Johnson syndrome and Rotter syndrome. Again, in these 2 cases, the same thing happens, that inside the liver cells, the conjugation is poor, the conjugation is done, the exportation from the cell is poor, exportation, exocytosis is poor, and Rotter syndrome and Stevens-Johnson syndrome. Again, in this case, you will find the alkaline phosphatase and the gamma GT, absolutely the gamma GT is concerning. This is definitely higher, on the higher side. In comparison with the aminotransferases, they are normal. The Stevens-Johnson syndrome and the Rotter syndrome is concerned, the enzymes, they are increased, gamma GT, alkaline phosphatase, but not a higher level, but significant increase. It is normal liver enzymes. They are not normal, but they are on the higher side. The Stevens-Johnson syndrome and the Rotter syndrome are the hereditary disorders. So what happens in LFT is this. You find in the dominant conjugated hyperbilirubinemia, the liver function test, total bilirubin will be increased. And the conjugated part of the total bilirubin will be highly increased than the unconjugated one. Secondly, in most of this, the ALT and AST will be increased to 3 times or more than that if it is hepatic in nature, hepatocellular jaundice. Intrahepatic cholestasis, extrahepatic cholestasis, they are increased but not higher levels, but absolutely the markers of the alkaline phosphatase and gamma GT, which are very, very higher side. Gamma GT is more higher in intrahepatic cholestasis, and alkaline phosphatase is more higher in cases of the extrahepatic cholestasis. So this is the interpretation of the conjugated hyperbilirubinemia and the liver function. Hereditary disorders, the liver enzymes are not important at all, but actually the excretion is problematical in this case. The excretion to the canaloculi is blocked. So the liver enzymes, they are slightly increased only. Normal is not correct word we are using here. Slightly increased, insignificant higher side. This is the end of the session 2, and I will talk now about the case discussions afterwards, inshallah, on the session 3. I will see you on the afterwards, inshallah, tomorrow or day after tomorrow, with the case presentation and interpretation. Allah Hafiz.